Yes, that today we will discuss about the safety of the structure so far as this beam, slab, columns that is in building are concerned. When the load is applied over these components of building, bending will be occurring. So for safety of the structure, we have to find out the appropriate thickness required for these components. Since bending is occurring, we found this appropriate thickness for these components by using bending equation that m by z is equal to flexural strength, that is sigma CBC we will take, that is for section and depth for the concrete section. That is how much depth of concrete that that is required for these components depth. So we will find by using bending equation, of course. Now this thickness will be checked with respect to deflection. It is must. So how you will find? We have discussed already this thing that deflection can be taken as the delta FL square by 6 ED in case of concentrated load, where F is that bending stress, of course. L is a span along which bending is occurring. In case of slab, we will take the shorter span. In case of beam, that is a span of the beam. Whereas in column, that height of the column is bending, that we will take that much L. So FL square by 6 ED, whatever the grade of concrete we are using, we can find out the modulus of elasticity by using this formula 57 under root under FCK, where FCK is the characteristic strength of the concrete. For M30 we will take 30 Newton per millimeter square, that is FCK. We can find out the value for modulus of elasticity. D is the required depth which we have found by using bending equation. So in this way, that deflection can be found. In case of UDL, we will use the expression delta is equal to 5 by 24 FL square by ED. So we can find out the deflection. Now this deflection will be checked with respect to its permissible value, which can be given by a span by 350. So it should be within permissible limit. So whatever depth you have found, it should be checked with permissible value for deflection. Then a structure will be safe. Now this is the case for where bending is occurring. Now suppose a structure is made on the ground surface like pavement, a railway embankment, airfield, etc. In this case, upward swell pressure is acting. Thickness of aggregate required in pavement, it can be found, that is whatever load is occurring on this aggregate, which can be found from the ratio of the strength that sand layer in the bottom, then boulder, then grade 1 coarse aggregate, stone dust, bituminous, that is wearing coarse bituminous aggregate mixture at the wearing coarse, that is at the surface, will be provided. Now strength we are knowing, of course, that is for sand 20 Newton per millimeter square is to 40 Newton per millimeter square is to 30 Newton per millimeter, so like that for these ingredients used for pavement. Should be, that is for for long vehicle, that is which length is taken as 18 meter, width suppose 4 meter. So for that load, total load, that 1716 suppose ton. So we can find according to the ratio of the strength of these ingredients used in pavement, that is load coming on this sand layer, boulder, this coarse aggregate, etc. Now how much will be the thickness? Whatever load is coming, suppose on the sand layer, that load divided by length. Length is more than width, of course, that is 18 meter is length and 4 meter is width of the vehicle. One vehicle, the load of one vehicle is to be taken. So 18,000 into T, whatever the thickness we will provide, that should be, that load divided by 18,000 into T, this should be equal to 10% of the compressive strength, which is 20 Newton per millimeter square for sand. So you can find out the thickness of the sand layer, similarly for coarse aggregate, etc. So in case of the structure made on the ground surface, that load is coming from top, upward swell pressure, of course it should be more than the load coming from top, so that settlement will not occur. So what happens, that whatever material is in between, that is suppose aggregate, it is subjected to elongation, that tensile strength will be there, that's why thickness will be found from the tensile strength of that given material. Now problem is that penetration of water, it is very, suppose 2 meter depth of water logging on pavement is there. Suppose that a heavy rain is occurring. So of course we have to find out that for 16%, so that is for soil, that is water absorption, we will take the penetration depth, that factor for soil 0.6. So for 2%, suppose this sand layer, that is water absorption 2%. So for 2% we can find out that factor. For coarse aggregate, of course, it is also 2%. So in this way, that and for bituminous aggregate mixture, that we can find out the water absorption will be different, of course, suppose 5%. So that ratio, we will take this ratio of this bituminous aggregate mixture plus this whatever sand layer, coarse aggregate, according to its water absorption. We will take the average, of course. Now it's of course whatever structure is made on the ground, that compressive strength, that is whatever load is acting, that should be checked with its compressive strength of that material. That compressive strength of that material should be more than the load coming on that material. In case of bending, that bending stress of that given grade of concrete, of course, it should be more than the load coming on the structure. This is the difference, that in case of bending, in case of this upward soil pressure where it is acting, that is on the ground, the structure is made on the ground. So compressive strength of that material should be more than the load coming on that material. So of course this compressive strength of this sand layer, aggregate, etc., bituminous aggregate mixture, which is strength is 140 Newton per millimeter square, of course, and aggregate, that is 30 Newton per millimeter square, like that. So its strength is very high as compared to soil. Soil has only 0.2 Newton per millimeter square. So that's why we will take the average, that is for soil 16%, we will take that 0.6 factor penetration, that is how much it will take place. So for 2%, that is water absorption for aggregate, we can find out the factor. For bituminous aggregate mixture, for which is 5%, suppose, we can find out that factor. We will take the average, that is for bituminous layer and aggregate. So that much factor, suppose 2 meter water logging. So of course water is penetrated from top to bottom. It will go into the underlying soil. So we will take in this case also ratio. Whatever ratio for aggregate, whatever factor you have found for bituminous layer as well as aggregate, taking the average or according to its water absorption. So that is to 0.6x, of course. That factor for soil, underlying soil, should be, that is equated, that is represented by 2 meter whatever depth of water logging. So in this case, that we can find out the depth of penetration into the bituminous layer, aggregate, etc., and it will go to the underlying soil. That is 0.6x. Whatever x you have found there, so 0.6 into x, that will be go into the underlying soil. So penetration of water will take place from top to bottom, that is it will go into the underlying soil. Now I have told that this where bending is occurring, that for safety of the structure, appropriate thickness as well as it will be checked with the permissible deflection. In case of a structure which is made on the ground surface, it is checked with the settlement. Okay, because deflection is less. Okay, the upward soil pressure will take place, will take the load coming from top. So deflection is very less. But so far as whenever water penetration into the underlying soil will take place, the settlement will occur. Because suppose according to this ratio, that is whatever factor we have found for bituminous layer as well as aggregate plus underlying soil, so water will penetrate according to 0.6 into x, whatever x you have found. So it will go into the underlying soil. Suppose 1.64, suppose, meter, it is going below the very water logging is there. So that much soil, that is 1.64, of course aggregate, when it will be in saturated condition, its strength will be very less because its water absorption is very less, that is only 2%. 16% for soil in saturated state, 50% of the bearing capacity of soil is reduced in case of saturated state. In case of moist state, 25% of the bearing capacity of soil will be reduced. So in saturated state, suppose that it will go, that is water logging, it will go into the underlying soil. So for 16%, that 50% is reduced, suppose saturated condition. So for this that 50%, so for aggregate, suppose 2% is their water absorption. So how much strength will be reduced? It is very less. That for aggregate, water absorption is very less strength will be reduced. But there is something reduction in strength. So we have to provide more thickness. That is, in dry condition, whatever that thickness you have